Alright, so I'm gonna go straight to the point. Oh yeah, I think it's because I moved the mouse or something. Double fault doesn't always happen, but sometimes it does. Oh, not important because alright, so this is hold. I'm holding N, Nancy, and then I release. So that red checker is. So I'm not actually decoding and parsing what is being sent. I'm just doing red on white for that. So how this works is and we're gonna start there. So this is just initialize terminal. That's good old stuff. So we want an interrupt descriptor table. That's the one that says that. So it has a bunch of fields, but pretty much the most important one is not this one. All right, so this is a function, and this is an interrupt gate. That means that you can't call the interrupt within itself, right? So when you call it, it temporarily blocks the interrupt until you finish calling it. So 33 is the keyboard. I'm going to explain why. But yeah, that's a function which is defined here. This is the start. This is saving state. This means this is colors. So I think this is black, this is white, and this is red. Yeah, white, red. So that's the background. And then, so this is the high 8-bit of a 16-bit register called AX. This is the low 8-bit of it. So then we have background, foreground, and then this 8 byte is going to be, that 1 byte is going to be the, so 448. That 1 byte is going to be like a char, right? So 256 values. And I just have I have a real printf, but for now, because I don't want to call stuff, because I made tests and I was like, anyway, this is what happens. So this is basically just address of I equals that color, I plus plus. Right, so read, write to the address, add one, write, and save it. Then we say the PIC, that's the hardware that receives external hardware interrupt. So there's external hardware interrupt, and then there's like the internal hardware interrupt. The PIC is the one that received the one from the keyboard. So internal hardware is like if there's a fault or a trap or an error or any kind, and it's gonna do those. So yeah, and then restore the state and the function and iret interrupt return. So once that's done, we initialize the IRQs. That's just alright. So IRQ are the external hardware interrupts, and that just means we're disabling all of them. So there's 16 of them, disabling all, and then I'm enabling one. One is the IRQ1 is the keyboard. So pretty much like disable all except the keyboard. So enable the keyboard, disable all others. And this right there, remapping, is because the first 32 are for the internal hardware, and the after that from 32 onward is user defined. But what happens is because historical stuff, the well the external internal hardware are gonna the external hardware interrupt are sent to 0 to like 16, but those are already used. So what you do is you just add an offset. So so 0 is going to start, so hardware 0 is going to start at 32 and then etc. So, and since keyboard is 1 and we added 32 to that, that becomes the 33rd. And that's how it works. So when you press a key, what's going to happen is it's going to detect that you press interrupt external hardware 1 is gonna know that it's been remapped. This I just copied it from OS Dev. I'm gonna learn more about it tomorrow. But I did learn some of it, but I want to like really understand everything. I think I do, but you always think you do when you don't. So there's two of them because it's like 8 for one, 8 for the other. That's another historical stuff. But yeah, this is gonna do one. That's gonna add one to 30, add 32 to 1, 33, and then it's gonna execute this code right there, and that's gonna return to wherever it was. So for now, my kernel main is just I have just a while true loop, but well, once you return from kernel main, you also have just a while true loop with no interrupts. But yeah, you're not supposed to come to this place because what are you supposed to do here? So like normally you would do like your task scheduler inside of here. That just is while true, and then just context switch, round robin.